All right, so even before we go into um, computing or knowing how to find the SXY there, the SXX, the SYY, remember we talked about the correlation analysis being about determining a relationship between two variables. Okay, so how exactly do we tell if there is a relationship between the two variables? So now, the way we tell is by looking at the value of r that we get. Okay, so if we get the value of r that is the value of r that is a negative number. Okay, the value of r, when we have the value of r, remember we said the value of r is between -1 and +1. Now if we get any negative number value of r, then we say there is a negative correlation. Okay, or the relationship between the two events is inverse. In other words, if we were looking at eating meat, okay, eating meat, the example that we gave is eating meat and gaining weight. Okay, if the answer that we get after comparing the two variables using the correlation coefficient is negative, it means that when you eat more meat, you lose weight. It's a negative relationship. Okay, when you eat more meat, you lose more weight. Or when you I wanted to say when you lose more weight, it means you are eating more meat. But that's what that interprets. It's like there is a negative relationship between two events. So if it's passing, we could say between studying and passing, we could say the more people pass, okay, the more they fail. Okay, the less they pass, the more they study. Is it the negative relationship between passing and studying? If you study a lot, you will fail. Okay, so we would say the relationship between the two have a negative correlation. Okay, you study a lot, you fail. You study a little, you pass. So that is a negative relationship. So that's how you interpret when you get a negative number. We say there is a negative correlation. Just as I said, is that it means that one variable is increasing while the other is decreasing. Okay, then if r is equal to 0, okay, if we get r and that value of r is equals to 0, we say that there is no relationship between the variables x and y. Okay, so for instance, if it's gaining weight and eating meat, our conclusion would be there is no relationship between gaining weight and eating meat. Or if it is studying and passing an exam, we can conclude to say there is no relationship between studying and passing an exam. Or if it is going to work and productivity, we would conclude that there is no relationship between going early to work and productivity. So that is how we interpret. Then if r is positive, it means that there is a positive correlation or the relationship between x and y is very positive. Okay, concluding the examples that we gave, if it's eating meat and gaining weight, we would say the more you eat meat is the more you are going to gain. That is a positive correlation. The less you eat meat is the more you're not going to gain, if that English at all is correct. Okay, if it's studying, we would conclude to say the more you study, the more you pass. So that is the relationship that will be there. If it's productivity and going early to work, we would say going early to work has a bearing on productivity, and so on and so forth. Yes, then let's talk about how to find SXY. SXY will be equal to the sum of, so just as we did previously in the deviations, as you remember, we can find, we will multiply, we will create a column, okay, because we are going to have two variables, a column that will have X variables and a column that will have Y variables, as I will be able to show you. So now to find this, let me just doodle here. Okay, to find this, okay, to find that, you would have to create a column that will multiply the individual variables of X and Y. Then you sum it, it will give you this. Then here again, this would just be the sum of the Y variables that we have, the variables for Y. Then here just be the variables for X. Then we divide by how many they are. So that's how we are going to deal with that one. Same applies